Thank you very much for the opportunity to present my research. Of course, I did not do it myself alone. We had a whole team working on this. My presentation is named Determining the Effect of Screens in Exposure to Aerosols in Restaurants. First, I will go to the content of the presentation. I will give a short introduction. I will tell you something about the introduction, and I will show you some results, and I will conclude with the conclusions of this research. First, a disclosure sheet. It's very short. I do not have any potential conflicts of interest, howsoever. The background of the research was quite interesting. During summertime last year, the question came to us from the government: can screens in a restaurant protect people who are in that restaurant? Can they protect guests? Normally we have a social distancing process of 1.5 meters between different households. So if you develop that in a restaurant, you will see that there is it's very limiting to the capacity of that restaurant. So the question was, can screen help us to reduce the 1.5 meter distance in a safe way? And is there a relation with the ventilation system or the ventilation rate? I will come back on that later. So the main research question for this research I will present you very shortly is how to determine the effect of protective screens in a restaurant setting. And this project was funded by the Dutch Ministry of Economic Affairs and Climate Policy. The method, well, we gave it a lot of thought. How can you measure in practice what the effect is of a protective screen in a restaurant setting? First, we did some measurements in real settings of restaurants without people, but then it was acknowledged that it was very hard because you are not in control of any of the conditions. So what we did was we went to other subjects, as I'm an expert in hospital ventilation, for example, and in hospitals we often use all kinds of simulating measurements with emission of aerosols, particles. And then afterwards you measure the particle levels, as is also done and described in ISO 14644 part 3. It's given in the Health Technical Memorandums of the UK. It's prescribed in the DIN standard and in the Dutch guideline 7. So there are all kinds of types of measurements in which you will spread aerosols by an aerosol generator, and it is a very defined quality and amount, and then afterwards you can measure it at different places and levels. So what we did was we used 0.5 micrometers particles as a guidance particle, because what we are interested in, does the screens have any effect on the airborne particles? And the airborne particles are approximately smaller than 5 microns. So all the bigger particles are more or less following a normal route, and they will be blocked by the screens. So that was not the field of interest in our study. Then we had another problem in this study, because what is good? It was already mentioned that there is a broad spread of emissions of particles by people doing different actions, taking different actions. And so what we did was we gave it a big thought, and we said, well, what is accepted in the Netherlands is 1.5 meter as a reference. So what we first determined was what is the exposure at 1.5 meters from a source, and then use that as a reference. So that's very important to understand. And what we did is we did a lot of measurements with and without screens, of course, and for that we used a mock-up. And the mock-up was not a real restaurant, but it was simulating a small restaurant. It was 7 by 9 meters and 3 meters high. On the right hand side you can see the particle emissions that are coming from the generator. So you can see we know quite good what the emission of particles is and what the distribution of particles is. And these are the screens we used. This is a full screen, and this was a half screen. And they were open at the floor because not to limit the airflow that much. Well, what experiments did we perform? We performed a lot of experiments. What we did is we examined two types of ventilation systems. One with linear diffusers close to the ceiling, and with scroll diffusers just mounted in the ceiling. We had three different ventilation rates, and ventilation rate here is defined as air with a relative low particle level that was entering the room. We used a low ventilation rate that was about 900 cubic meters an hour, because that was according to the Dutch Building Act. That was the minimum level we should use. So that was also used as a reference. Then we used a medium amount of ventilation, 1700 cubic meters an hour, and a high volume. And the high volume, that's more or less the amount you get from an extractor hood in this type of restaurant. So it's quite typical for this size of a restaurant. And what we did is we used three different setups, excluding the reference setup. I will show them in a minute. Here you can see a photo of the setup of the mock-up. You can see a small open kitchen on the right hand side. You can see a particle counter. You can see some heat loads that were simulated as guests. You can see the tables, you can see the screens, etc. The procedure was also quite important. When we started the experiments, we first had 10 minutes to measure the baseline condition, because even if you admit a low level of particles, you still will have some in them, and that's the reason why we first measured the baseline condition and the baseline concentration. Then we started the emission. And during the emission phase, after each 5 minutes, we had a walk through the mock-up, and it was according to a protocol. So we did it 3 times. After 5 minutes, after starting the emission, after 10 minutes, after starting the emission, and at the end of the emission. And then we stopped the emission, and then started the process of recovery. And then we could see how the recovery rate in that typical situation was. And then after 45 minutes we stopped an experiment. Each measurement was performed at least 3 times, so we have some kind of analysis of the variance that we could measure. If we look to the first setup, it is presented here. This is the mock-up of the restaurant. You can see the kitchen on the right hand floor, at the right hand. There is the exhaust hood, the ventilator, the measuring device for the amount of flow, and then we use the HEPA filter just to get rid of all the particles we emitted right here. And the red spot is the place where we emitted the particles according to how people breathe. That was an outlet velocity of 2 meters a second and a certain amount of aerosols. At this position, at the next positions, we emitted it, you can see it here, and we just measured it at 4 different positions. These were the positions where the particle sizes were measured. The yellow lines were the walking route during the 5-minute walk. This was a setting with 12 tables, 26 chairs, and 21 restaurant guests. In the situation with diffusers, we used 5 diffusers. They were mounted in the ceiling, and this was the type of scroll diffusers. We also used linear diffusers, and they were mounted in the wall in the opposite of the kitchen. So there was more or less a better condition of the flow. The different setup with the screens are given in this picture. So you can see that the tables on opposite sides of the screens are much closer to each other than at the other side, so you can harvest more people, and that's better for the economics of the restaurant. So here we used 6 screens and 1/2, 13 tables, 32 chairs and 22 restaurant guests. So you can see the other different setups in this picture. What we did during the measurements, here you can see a figure of the concentration, and I put on where the emission starts, where it stops, etc., etc. And there were two main outcome variables, and that were the total exposure and the 100-fold recovery time. And the 100-fold recovery time, that's a measure that's often used in clean room technology and in operating rooms. So here you can see the baseline measurement, and it's about, well, you can read it yourself. Here we start the emission. Then you can see that there is an increase of the concentration of the small particles, the 0.5 mu particles and bigger. Here we stop the emission, and then you can see a slowly decline. And based on this formula, we can calculate what the 100-fold recovery time was. So that are two very important outcomes of the research. The total exposure, so that's the surface between this line, and the 100-fold recovery time. If you look to the low ventilation rate, in which R is the reference situation without any screen, you can see E, B, and C are the situations with protective screens used. And then you can see that the total exposure with the screens is lower than in the reference situation. So we see in this situation, in all the situations, there is a positive effect of the screens, although it's based on airborne particles. That's also an interesting one. And we can see that the difference between the reference and situation B and C are significant, and between A and R they are not significant, but they're still a bit lower. And if you look to the 100-fold recovery time, we can see that there seems to be an increase of the time, and that's a bad situation, because we want a decline of also the recovery time, because the shorter the recovery time is, the better. So that's also a strange result. If we look to the total exposure and the recovery time, we see a very clear line, and that was also expected, and that's correlated to the amount of ventilation. So the lower the ventilation, the worse it is. So in all the situations, if we increase the ventilation by a little bit, or the extractor hood in the kitchen is on, then we have a much better situation that is allowed according to the Dutch law to the low ventilation level from it was 900 cubic meters an hour. So that's also an interesting finding. So the higher the ventilation rate, the better it is for the total exposure and the recovery time. Of course, that was quite obvious, but here we proved it. If you look to different setups, you can also see that with a setup R, this is the reference situation with low ventilation, that's always the worst situation. So all the situations with the screens with a higher, medium, or a high ventilation is always better than the reference situation. And that was also the reason why some restaurants could open during the summertime using protective screens at the outside faces of their premises. The conclusion is that the amount of ventilation is the most determining factor for the total exposure and the 100-fold recovery time. We know it from theory, and here we proved it very clearly. The medium and high ventilation qualities result in a lower total exposure than the setup. It was also interesting that there is not a significant difference between the line diffusers and the shrill diffusers we used in this experiment. And what we can say is that with the low ventilation amount, the total of exposure of the three setups with screen is lower than for the reference without a screen. So a screen can help to protect even against airborne contaminants in this setup. So I'm through to this presentation, and I would like to give the word to Reza Asfari. I hope I pronounced the name right. Thank you for that.